Hi, welcome Geometry. We're looking today at our Saxon Geometry. And I hope you all have had a great summer and are excited about starting back with us in our Saxon curriculum. So part of your summer learning should have included the first 15 lessons of your Saxon Geometry. And I know that sometimes when we start back into something new, we tend to just rush through and just think, I just want to get by and get this done. But I really want to encourage you. The foundation has been laid in your Saxon Algebra 1. So you have learned those fundamental key concepts about variables and about like terms. And we've just done so many fun things in Algebra 1. I know they were fun, right? So now that we're jumping into geometry, we want to make sure that the foundation is laid and set properly. And in your first 15 lessons of geometry, you're going to find a lot of terms. And I know that sometimes it's easy just to breeze through and go, these are words. I just want to do the math of it. But it is crucial and super important that you know what those terms mean. Because geometry is a little bit different than algebra. Now you'll see similarities and you'll see when we're doing some algebraic type things in our geometry class. But one thing that I really love about geometry is it stretches our reasoning. If I know this and I need to know this, how can I get there? You know, sometimes I find that people who really love algebra don't always love geometry as much, because sometimes they say, I just want an algebra problem where they give it to me and I just solve it. So sometimes it can be a little bit rote memory for our minds where we say, just tell me what I got to do, right? Well, geometry doesn't always work that way. We say, all right, this is what I know. This is the given. And I need to figure out this, what terms, what definitions, what theorems have I learned that make a fact statement that will lead me to this truth. So I think that's really important. You know, in a world where people are constantly trying to change what is truth, in a world where they're constantly trying to say that truth might be relative to how you're feeling that day, aren't you thankful that math is absolute? 2 plus 2 will always be 4. And that's because math is given to us by our Creator, by God Himself. And so math has a beautiful language that is absolute truth. And I'm very thankful for that. But I want to encourage you that geometry does build on what you've already learned in your foundation of Algebra 1. Now, some of you might be taking geometry after having Algebra 1 and Algebra 2, and that's great. The only prerequisite for geometry is Algebra 1, and the only prerequisite for Algebra 2 is Algebra 1. So you can take it in either order, so it does not matter. But I do want to point out to you that it is crucial and super important to know your terms. So lesson 13 was one thing that I want to point out to you. It talked to you a lot about introductions of triangles. You have to know those types of triangles. Equilateral means they're all equal. Isosceles, I saw two sides are the same. And then scaling, no sides are the same. All right, acute triangle, all the angles are less than 90. Obtuse, only one angle is more than 90. And then a right triangle, only one of the angles is 90. You couldn't have a triangle with more than 90 because we all know every triangle has how many degrees? I hope I heard you at home say 180 degrees. Same as a straight line, right? That's how many degrees are in every triangle. It also told you the area of a triangle. You have to know that. 1/2 base times height. We did that in Algebra 1 as well. So I know that that's probably something that you're pulling back from. I hope you didn't file that away too far. I hope you're pulling that back up. Now, lesson 14 talked about conjectures with counterexamples. You know, in the world with lots of media and lots of research that's done, you have to constantly evaluate. Is that truth? Is that one time I had a lesson in one of my middle school classes where it talks about how sometimes people can do some type of media like maybe a circle graph or maybe a picture graph, and the idea can be a little bit misleading. I remember we were studying for a standardized test, and one of the salesmen had tried to show similarities between all the salesmen. But what was interesting was his cars that he sold were bigger than the others, but the value was the same. So it made it look it made it look like he had sold more than others who he was competing against in a contest to sell more. And so sometimes how data is presented can be misleading. So that's why I think geometry is so important, that you start that reasoning process. And I think that that certainly is something we need to carry through with us, not just this geometry class, but our entire lives, that we constantly filter what is truth through God's word and constantly evaluate. You know, if I were to take a poll and I said, I want to know how many people bought produce in a local store. Well, would I just go in produce and stand and count the people that came in produce? Well, that wouldn't be an accurate survey, would it? Because probably most of the people who are in produce are going to buy. But I can't just stand at the register. What if someone came in and the produce wasn't what they needed and walked back out? So I would need to stand at the doorway to know how many people came in and how many people left, and ask, did you purchase produce today? So you want to have an accurate polling of the data you're trying to present. So that's really important in our world. So lesson 14 talks about counterexamples. If you're saying that something isn't true, then you need to give an example of why it's not, right? Not just say, that's not true, right? I've got to give a reason for it. A counterexample says, well, this is not always true because, and gives a reason. I apologize. That's Sadie, and she is my miniature schnauzer, and she wants to be part of this video as well. Now, lesson 15 is super important because it introduced you to polygons. Now, what is a polygon and what is not? Well, polygon has to be closed, and a polygon cannot have any rounded edges. So everything has to be straight lines, and it has to be closed. So your book showed you that. Now, on page 90, you have a chart that explains how many sides each polygon has and then what its name is. So it goes all the way to triangle, of course, 3. Now, you can't have a 2-sided polygon, because if I had 2 sides, there would be no closure, right? So the smallest polygon is 3 sides. So that would be a triangle. Quadrilateral. Now, there are many different types of quadrilaterals. If all the sides are the same and all the angles are the same, we know that that quadrilateral would be a square. But you could have a trapezoid, you could have a parallelogram. There are so many different types of quadrilaterals. A pentagon, a hexagon, a heptagon. So your book goes on and on. Nonagon is a 9-sided. Decagon, deca means 10, so decagon. Hendagon is 11, and then dodecagon is 12. Now, a lot of times in books, you'll see n-gon, and that just means n number of sides. So if it had 32, it would be 32-gon. So an n-gon. All right, now, a regular polygon means all the sides and all the angles are the same. So a regular, if you were taking a standardized test and they told you that it was a regular triangle, then you know it would be equilateral. All the sides and all the angles would be the same. If they told you it was a regular 4-sided, it'd have to be a square, because that's the only quadrilateral that all 4 sides are the same. All right, so those terminologies are super important. Now, we've reviewed a little bit. Let's jump into lesson 16. So lesson 16 says finding slopes and equations of lines. Now, this should be review for you from your Algebra 1, but always it's good to jump in and review. So it talks about warming up some of your vocabulary that you need to look at. And I would encourage you to review over that vocabulary. Very important. Don't forget that slope is the measurement of your rise over your run. And you don't want to run first and then rise. That would be, you'd be having a nightmare, right? So you got to rise first and then run. So the measure of slope is rise over run. And then our standard equation that we write for to show slope would be our slope intercept. Y equals mx plus b. That's our favorite best friend from Algebra 1, right, friends? We remember that. All right, how do we find slope? Your book shows you at the bottom of page 96, y2 minus y1 over x2 minus x1. Now it shows you how to graph a line. So all of this should be reviewed from Algebra 1. Now you may have had a different curriculum in Algebra 1. So if so, you might need to spend a little extra time. And there are several websites I would encourage you. There's a virtualhomeschool.com, and they have Algebra 1 practice and also geometry practice. There's also Khan Academy, and that's spelled Khan, Khan Academy, and every concept you can imagine. So if you're struggling with slope of a line, or how to draw a line, or how to find slope, you can go there and review. I have a few other practice videos where I review over slope, so you might want to check that out as well. But it's very, very crucial as we jump into geometry and move forward that you review over those, that you understand what is going on with those. Now, let's look at page 99, and it has your lesson practice. Those will always be the lettered problems, and then the numbered problems are the actual lesson. So the lesson practice, letter A, determine the slope of this line. And they give you a graph here so you can see it at home on your book, but they give you a picture of that line. Now they give you the points. Now a couple of things you can do. You can just take those 2 points and do the math of it. I like to write them and then stack them and then just subtract y2 minus y1 over x2 minus x1. But the great thing about having a picture is you can just count out slope. Start at the bottom and just count up. So it went up. Remember, slope is rise over run. So I just count up. And I would encourage you, grab your book and count up with me. We're at 1, 2, start there and just count up. 1, 2, 3, 4, 5, 6, and then it goes over 2. Do you see that? So up 6 over 2. So if I go up 6 over 2, that would be 6 over 2. That reduces to 3. All right, so what is my slope? Well, it's positive because my line is rising. And just like you read a word from left to right, you read a line from left to right. It's rising, positive. So my slope is 3. And then the other thing I'm looking for is where does it cross the y-axis? We'll follow down the y-axis until you see the blue where it crosses. And I see it crosses at -1. So friends, how do I write that? Well, I write that in my best friend formula. Do you remember? Y, so I'm on letter A, y equals mx plus b. So I say y equals, and we figured out my slope is 3x, and we saw that it crossed at -1. So b is my y-intercept, and m is my slope, right? Just the measurement slope. So it's just the measurement of its rise over run. So I know that it went up 6 over 2, and 6 over 2 reduces to 3. So that's why I plugged in the 3 for the m, and it crossed the y-axis at -1. So my equation is y equals 3x minus 1. Now it says on letter B, use the slope formula to determine the slope of the line passing through, and it gave us 2 points. So let's take a look at that. So here I am at letter B, and it gave me the points. And the points are 1, 2, and then 3, 4. And I always like to stack them because I think it's easier. My equation says it's y2 minus y1 over x2 minus x1. Remember, it's the rise over the run. That's how I remember it. But if I stack them, this would be 0.1, this would be 0.2, this is x, and this is y. So y2 minus y1 over x2 minus x1. So if I stack it, I just start at the bottom right, and I go 4 minus 2 over 3 minus 1. So what is 4 minus 2? 2. 3 minus 1 is also 2. 2 over 2 reduces to 1. Therefore, my slope is 1. So I'm going to go ahead and write equals m. We denote slope as the letter M. Now it says use the slope formula to determine the slope of the line passing through that point. We're finished. If it asked us to write it in an equation, then we would need to take one of these points and the slope and then solve it using y equals mx plus b. It didn't ask me for that. It just asked me for the slope. So I'm finished with letter B. Now, letter C, use the graph to write an equation of this line. Now, it did not give me any points, so I need to take a look at it. So on letter C, I've got to figure out what the slope is. So you need to find two places where it crosses exactly. And I see that it crosses, the y-intercept is 4, positive 4. And then I notice another place is 4, 2. So I'm going to count out the slope. It rose up 1, 2. So it rose 2, and then it went over 1, 2, 3, 4. So one thing I want to point out to you on letter C, it's falling. So it's going to be a negative slope. And it rose, or it went down 2 and went over 4. So it went down 2 over 4, down 2 over 4. Slope is steady, right? So it's regularly, in this case, falling because it's negative. So I can reduce that. My slope is negative 1/2. So you could even count down 1 over 2, down 1 over 2 is down 2 over 4. Same thing, it just reduces. Now, that it says use the graph to write an equation. So this problem, letter C, is not asking me simply to just find the slope, it's asking me to write the equation. So remember my best friend in algebra, y equals mx plus b. So y equals, I know my slope is negative 1/2 x, and then plus b, my y-intercept. So what is the y-intercept in C? Well, the y-intercept is 4, so I'm going to write plus 4. So do you see, just looking at a graph, it can become very simple as long as I first find my slope and then my y-intercept. Y equals mx plus b. Letter D, write the equation of the line that has this slope and passes through this point. So what do I do? Well, let's, on letter D, they gave us the slope this time. So letter D, they said that the actual slope is 3 over 2. So m equals 3 over 2. And then they gave us a point. Now 4, negative 1. Now some of you that had me in Algebra 1 know that there's a shortcut called point slope formula, and you can use that. But just for consistency, I'm going to use my best friend formula, y equals mx plus b. Now I know my slope, they gave it to me as 3/2, right? So I'm going to go ahead and put that in parentheses. Now, I know this is x and this is y, so if I know one point, I can plug in the x and the y here and then solve for my b. So be careful because x comes first, but in my equation, y comes first. So I'm going to plug in negative 1 for my y, and then I'm going to plug in 4 for x, plus I don't know what my b is, so I'm going to keep b as a variable. So I've got negative 1 equals 4 over 1. 2 goes into 4 2 times. I reduce. So now I've got both of them over 1, so it's just 3 times 2 is 6 over 1, or just 6 plus b. Now, my goal is to get b by itself, so I'm going to subtract 6. I'm going to undo it. So I'm going to end up with b equals negative 7. Now, I'm not done because it asked me for the equation. So what is my equation? Y equals mx plus b. So this was one point on the line. This was its slope. Now I know the equation of that line is y equals 3/2 x minus 7. Remember, all I need is the slope and the y-intercept. So that is my answer. The difference between B and D was D asked for the equation, B just asked me for the slope. So make sure you're looking out for that. D actually gave me the slope, so it wasn't as difficult. Now, E, F, and G are on the next page, page 100. Now, it says write the equation of the line that passes through, and it gave us 2 more points. I'm not going to do that one because we just solved one of those. But letter F says graph the line with this equation, and G also gives us one. So one thing you want to be on the lookout for is both F and G are not in your slope-intercept formula format. So you'll need to rewrite those to get them in the proper format so you can easily graph those. So letter F says y equals 3 minus 1/3 x. They're a little bit sneaky there, and they're not trying to confuse you. They just want to know, do you understand what should go? So it's y equals mx plus b. So your constant should always go last. So let's rewrite it in the right order. Negative 1/3 x plus 3. There's no sign in front of the 3, so it's understood plus. Now I can graph this very easily, right? When I'm graphing, I always start with a y-intercept first. So here's x, here's y, 1, 2, 3. So I start on the y-axis and I put a dot at positive 3 because that's my b, my y-intercept. Now what's my slope? It's negative 1/3. That means that my line's going to fall. So I am going to go down 1 over 1, 2, 3. And I put a line, or excuse me, put a dot here. Now I did put little dots here so you could see me counting, but I don't actually write those there. So I just need 2 points to make a line. Now you could actually do it again and go down 1 over 3 more. Or you could even go up 1 and go back 3. Because your line is falling, it would go in that order. So there's my line. All right, it should be straight, but I didn't use a ruler, so at home you might want to use a straight edge. But that line is constantly going down 1 over 3, down 1 over 3. That's how the steady slope takes place. And it crosses the y-axis at 3. Now let's take a look at G. Graph the line with the equation 3x plus y equals 6. Now, those of you that are watching, you might remember what format this is. Do you remember? I should give bonus if you can call it out at home. You'll have to text me and tell me if you were able. But we call this standard formula. And what's great about standard is it's easy to find your x and y intercepts. So you might be able to do that very quickly by doing your x and y intercepts and graphing that. But just to be consistent with y equals mx plus b, let's rewrite this. So I got to get y by itself, so I just subtract 3x. So I end up with y equals negative 3x plus 6. I can't combine those. How come? They're not like terms. I love it when you guys say good math reasons. All right, they're not like terms. So now I can graph this. So what would it look like? Well, it would cross at 1, 2, 3, 4, 5, 6. So on the y-axis, it's going to cross at 6, right? Here's my x-axis. Now so my y-intercept was positive 6. And again, my slope is going to be negative. So I'm going to go down 3, and this time only over 1. How come? It's a whole number. All whole numbers are over 1. So I went down 3 over 1. I could go up 3 and back 1, but I have to fall because this is a negative slope. And notice it went down 3 over 1, down 3 over 1. That should have been closer over here, shouldn't it have? But you guys get the idea. I didn't quite go through my line the way I should have. So at home, make sure you're using a straight edge and you'll be more precise than I am on this whiteboard. All right, so that is lesson number 16. And I hope that as you're doing these, that you are reviewing over these and understanding, because this terminology that we're studying is super important, and it's important that you're understanding and following along as we review and go over those. Now, lesson 17 in geometry covers conditional statements. Now, do you know, in our world, there's lots of conditional statements. We can even find conditional statements in the Bible. Do you know that God gave a condition? He said, if my people who are called by my name will humble themselves and seek my face and turn from their wicked ways, then will I. Do you see that's a conditional statement? If you do this, this, and this, then this, right? I bet your parents have given you conditional statements. I actually gave one of my children one today. If you clean your room, then you can. Great conditional statement, right? Y'all hear that at home too, right? If you get this grade, then we will. That's a good one, right? So if you finish this, then we will get to go outside and play, right? So those are conditional statements. If and then. So it's important to know what you're looking at. So the book kind of shows you a statement. If P, then Q. Now it talks about the converse of something. So that would be if Q, then P. So in the first case, P came first, then Q, then the converse of it, they flipped it. Q came first, then P. The inverse is the negative of P. So if you don't clean your room, then you don't get to, right? So then the contrapositive, so that's the flip and the negative, right? If you don't get to go there, then you didn't have your room cleaned, right? All right, so those kind of terms are super important to make sure that you understand. All right, now your book talks about state the hypothesis and conclusion of this statement and its converse. If a polygon is regular, then it is convex. So we understand that's a conditional statement. If, then, right? Now it says, then give its converse, right? If it's a convex, then it is a regular polygon. You're just flipping the ifs and the thens, right? So that's what those are. All right, letter B. If the statement in problem A is true, is the converse true? So, sometimes you can find, like, every square, right? Every square is a quadrilateral, right? Because I know that it had to have 4 sides and all 4 sides are the same, so therefore a square is a quadrilateral. But is every quadrilateral a square? No, it could be a trapezoid. So that's why it's super important to know that just because it's written one way, the flip of it isn't always, right? If it's a deer, then it is a mammal, right? Because we know the characteristics of mammals, that a deer would be a mammal. But are all mammal, if it is a mammal, then it is a deer? No, not all of them, because you just heard my dog a few moments ago, and that's also a mammal, right? So that's important to understand. And I know right now you're going, why is this in geometry? Because it's helping us to process through reasoning. And that's why it's super important. All right, so determine the contrapositive of this statement. If 2 angles are complementary, then the sum of their measures is 90. So if something is complementary, it means it adds together and makes 90 degrees. Well, the converse of it is if the sum of the angles measure 90 degrees, then the angles are complementary. We switched the 2, right? But it said the contrapositive, so you have to do the negative of each, right? And you have to flip them. So if the sum of 2 angles measure is not 90 degrees, then the 2 angles are not complementary, right? We flipped them and we did the opposite of each, right? So that's what it means by the negative, meaning it's the opposite, right? All right, so I just practiced some of those with you on lesson 17 because I wanted to make sure that you thought through that reasoning. So I'm going to do this video just lessons 16 and 17, and if you'll join me again later this week on 18 and 19, I appreciate it. So I'm really proud of you guys. So we did 16 and 17, and I would encourage you, don't wait until last minute. Don't cram all your lessons into one day. I hope you're not waiting until the final day and going, I've got all my lessons due. Math is built line upon line, precept upon precept. I know that life can sometimes get busy and sometimes we can get behind and have to get caught up. But as a habit, as a routine, make sure you set aside each day. Math is line upon line, precept upon precept. So don't rush and don't try to cram everything in because that's not going to go into your long term. And in geometry, a lot of reasoning has to take place. So you're going to have you ever done math when you're not quite thinking all the way, you're just kind of working out mindlessly? Well, that's not how geometry works. You're going to have to reason and think. So I appreciate you working hard and making sure you're consistently doing that. So thanks so much. And I'll see you guys next time.